Welcome to Math 2318, Section 3.1 on determinants. We've seen determinants a little bit before, so now we have a more in-depth look at them in Chapter 3. So, if I have a 2 by 2 matrix shown here, the determinant of it, which you'll see it written as det of A, or two vertical lines that look like absolute value. The determinant takes a matrix and it generates a number. And that number in a 2 by 2 case is the product of the downward diagonal minus the product of the upper diagonal. Now, beyond a 2 by 2 size, we have what are called positional signs. The positional signs are minus 1 to the I plus j. I is the row number, j is the column number. So you sum those two together. So what you're going to get is minus 1 if the sum is odd, and a plus 1 if the sum is even. So in the 3 by 3 case, I've got a 1, 1, and so that's a plus because the sum of these two is 2, minus 1 squared is plus 1. Here at 1, 2, what we have, here at 1, 2, we have 1 plus 2 is 3, and minus 1 to the 3 is negative 1. So each of these places has a positional sign that's either a plus 1 or a minus 1. So again, Aij, wherever we're talking about, there is an associated sign that goes with it. Now with that, when we form the determinant, we can expand down any row or column by something called cofactors. So let's say I've got matrix A here. Here's matrix A, and I'd like to find the determinant. If I expand down the first column, all right, so I'm talking about the 1. You cover up the column it's in, the row it's in, you get this 2 by 2 cofactor. The positional sign for A11 is positive 1, so I get a 1 times this 2 by 2 matrix. When I come to the second position in that column, that's A21. 2 plus 1 is 3, minus 1 to the 3 is a minus 2. So cover up the row and column it's in, I get this 2, 3, 1, 5 cofactor. And when I get to the last position in that first column, this is a 3, 1. 3 plus 1 is 4, minus 1 to the 4 is positive 4. And again, cover up the column and row it's in, and I get this cofactor. So from there, we just do each of the 2 by 2s. So 5 minus 0, 10 minus 3, 0 minus 3. So 5 minus 0 is 5, 10 minus 3 is 7, 7 times the minus 2 is a minus 14, and 4 times minus 3 is a minus 12, so I get a number that's minus 21. Okay. So let's take a look. In question 1, they say find the determinant of this particular matrix. They want me to expand across the first row. So how did the signs go again? They go plus, minus, plus, minus, plus, minus. All right, so I'm going to get a positive 3 minus a minus 4, so a plus 4, and a plus 3. I get the cofactors by simply covering up the column and row it's in, giving me the 2 by 2 cofactors. And so when you grind that out, we get a determinant whose number is minus 49. All right, now what if we went down the second column? All right, so here is the same matrix. I'm going down the second column. Positional signs are minus, plus, minus. So that's going to be a minus 4, plus 1, and a minus 4. To get the cofactors, simply cover up the column it's in, which is column 2, and then whatever particular row we're talking about. So if it's here, if I cover up this column and this row, I get 3, 3, 1, minus 2. And so I do that to get my 3 cofactors, which are 2 by 2 determinants, giving me exactly the same number as we got by expanding across the first row. So however you expand by doesn't matter. It can be the first row, second row, third row, or whatever column. The idea is you're going to pick whichever row or column makes the calculations easier. Easier in the sense you've got more ones or zeros. Okay, now let's see. In question 2 here, they want to expand by the first column in this 3 by 3. So again, just to remind us how the signs go, I'm going to get a plus 6, minus 9, and a 0. So 6 minus 9, that's where the minus is hiding, and 0 for the last one, which is positive. To get the cofactors, simply cover up the particular column and row that it's in. And by doing this and simplifying, I get a determinant of minus 102. All right, let's see. In question 3, they say, all right, find the determinant of this 4 by 4, and we're going to pick whichever row or column seems to be the easiest. Well, again, I'm looking for something that has lots of zeros or lots of ones. So I'm seeing I've got this first column, which has a 4 and lots of zeros. Or I could expand down this last row because, again, I've got lots of zeros and this single element. How do the signs go? Well, let's see. The signs for a 4 by 4 would go plus, minus, plus, minus. Minus, plus, minus, plus. Plus, minus, plus, minus. Minus, plus, minus, plus. And again, this is minus 1 raised to the I plus j. And so if I go down column 1, then I've got a plus 4, and I've got this 3 by 3 cofactor. All right, but looking at this 3 by 3, I'm again picking the column or row that has the most zeros. So I'm going to expand by this first column. So now I've got 4 times minus 2, and then I get this cofactor, which is 2 minus 0. And so I get minus 8 times 2, which is a minus 16. So you're using whatever row or column makes the calculation the easiest. In question 4, let's see. We've got my original matrix, and they've taken row 2 and multiplied it by 3. So how does that affect the determinant? Multiplying a single row by a number. Well, let's see. Here's the determinant, AD minus BC. And in the second case, I've got 3AD minus 3BC. The common 3 factors out. So, what if I multiply a single row by a number? That single number comes out as a product times the determinant. So, multiplying any row by a number k means it's going to be k times the determinant of A. Alright, in question 5, we have two matrices, matrix A and E. The determinant of A is AD minus BC. The determinant of E is 1 minus 0, which is 1. Alright, and so they're stepping you through this particular scenario, that the determinant of the product is equal to the product of the determinants. So let's see, what is E multiplied by A? Well, let's see, 1 times A, K times C. Add those up. 1 times B, K times D. Add those up. 0 times A is 0, 1C. Alright, so here is EA. I've got the determinant of both E and A. So what about the determinant of EA? Well, the determinant of EA is just going down the downward diagonal times the upward diagonal. And now distribute these items in. And we notice that I've got a plus KCD and a minus KCD. Those cancel, and so I get AD minus BC, which is the product of the two determinants. Alright, so what happens in problem 6 if I multiply the matrix by a scalar? Okay, so here's matrix A. Ka not only multiplies k by a row, it multiplies k by every row. Well, let's see, what is the determinant of k times a? Well, I get a k squared AD minus a k squared BC. And so what you notice is now I've got a k squared that comes out. 2 rows, I'm going to get a k squared. In rows, I'm going to get a k raised to the power of n. And that concludes what's going on here with our first section on determinants.